Everyone, welcome to Data Engineers Launch number 60. Today's topic is going to be the first part of a series our guest speaker, Rahul Singh, will be giving on developing enterprise consciousness. The co-organizers for this event are Rahul and myself. If you're interested in being a guest speaker or being a sponsor for Data Engineers Launch, the same applies for our sister launch, Cassandra.Link. Feel free to reach out to me. My email is listed below. We're part of Data Community DC. Data Community DC believes in having a inclusive culture, so no matter your race, gender, sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is built up of a bunch of different organizations. We fall under Data Wranglers DC here at Data Engineers Launch. So if you're interested in all the various different events that are put on by Data Community DC, you can find out more at datacommunitydc.org. So what do we cover here at Data Engineers Launch? We cover everything that is data engineering, data wrangling, data cleansing, ETL, etc. So whether that's ingress to egress or everything in between, there's so much that falls under data engineering. And yeah, we're at Data Engineers Launch number 60, and there's so much more that we can still cover. If you're new here at Data Engineers Launch, feel free to drop a hi, hello in the Zoom chat or YouTube chat if you're watching on YouTube. Group rules, if you have a question, ask it. This is meant to be a community, but please be polite and courteous to the guest speaker as well as others in the chats. But again, because this is a community, please do share what you know with us. If you have any experience on the topic or if you have any experience in the real world, feel free to share it with everyone here. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So data engineering is a way of life for us. DataStax is a partner and a sponsor. GW University helps provide in-venue space when we have in-person events. We also have some organizational and institutional sponsors. If anyone has any jobs or is looking for a job or any meetups, hackathons, or conferences, feel free to drop any links in the Zoom chat or the YouTube chat, and we'll get them transferred vice versa. DataStax Astra has a build-a-thon that's currently ongoing. I believe the first month is over, but the second and third months are still up for running. So there's a round of challenges per month, and the top 3 winners of each round qualify to present their ideas at the demo day. So there's prize, cash, and swag prizes available for each monthly round, but as well as the demo day if you qualify and end up winning. Anant is hiring if you're looking for a full-time or part-time position and data platform operator, engineer, architect. You can reach out to us at careers@anant.us. Events, we have this event every Monday at 12 Eastern currently, and we have our sister launch, Cassandra Lunch, every Thursday at noon Eastern currently. And you can find out more at all of our events at anant.us/events. And with that, we'll go ahead and pass it over to our speaker for today, Rahul.
Hey, thanks, Arpin. Appreciate it. And in terms of questions, would like to defer the questions until later, just because there's such a broad outline of topics, and I'm not even done with completing the full series and sub-series yet. So we'll do today's session, and then we can do some Q&A. And that'll be good for me to actually put any changes for the subsequent items in the series as well. So let me know when you all can see my screen. I'm not sharing it now. And I'm sharing my whole screen because I do want to show an outline. So there's a series that I've come up with. There's a series that I've come up with as a result of both clients having the same questions over and over again at our team here, as well as folks inside the team that would like to learn more of the advanced concepts, and then recently clients wanting to be trained on this material as well. So what I'm presenting here is actually generally the same materials that we would be providing as training, but obviously I'm going to be condensing a lot of those. Each series or part of the series are probably 3 to 6 hours in terms of content, when we dig deep into it and we really get into the topics. So the fact that we're going to spend a little less than an hour on maybe these two today, and maybe I'll have to come back and do this another time. But each of these main topics we're trying to cover once every other week in less than an hour. So if there's material and details that I'm not able to get to, well, that's because there's more to it than just the overview. So today's focus is really to give you an overall introduction to what is developing enterprise consciousness and getting into the overview and survey of current processing frameworks. And we'll learn a little bit about what's the difference between a framework, what are the different types of processing, as well as what are the different workflow tools. And these are sometimes seen as the same thing, but they're actually very different. Next week, either we'll finish up, not next week, but the next time I do this, we'll either finish up this and then get to microservices and real-time architectures. This is actually a two-part, these are actually two sessions, but it makes sense to do it together in a webinar. And then pipeline design and processing, containers, frameworks, workflows, and services, frameworks, and workflows, they're more self-contained. In fact, they could be delivered separately from the rest of this stuff, and you guys would still understand what's going on. So developing enterprise consciousness, we'll get into what that means, but think about what consciousness is for a person. We're trying to help clients solve enterprise consciousness problems. We have a terminology around it, and I want to give credit to a friend of mine, Jeremy Epstein, who's a world-class marketer and is now really deep into the blockchain world. And we were discussing some of the things that we at Anant think of the future in terms of how businesses should work together. And he said, well, that's kind of like enterprise consciousness. And so that's really where the term came from a few years ago. And until recently, we've just used it internally. And until now, it hasn't been in the public domain. So this is the first time that we're putting it out there. And when we think about enterprise consciousness, it's really about doing it for all businesses. Although today, the technology that we use is generally for global data and analytics platforms for fairly large organizations. And our specialization is really in cloud neutral systems and not just on one particular cloud or the other. And that's by design. It's not that we don't like AWS or Google or Azure. We love those cloud providers. The reality is the trends in the market, people go in and out of different clouds. Things go from centralization to decentralization. So we want to make our strategy sound for future changes in the market and industries. Data analytics platforms are the central nervous system of businesses and business platforms. And every business has this business platform, and every business has some data and analytics platform. So when we think about enterprise consciousness, although we're talking about large businesses, the same general challenges that we're going to talk about apply to small businesses as well. Business challenges are how to run a business. We don't necessarily comment on how people run their businesses or what products they go after. And that's not where we really have much of an impact on our clients. They have experts that help them figure out their strategy. But once a business knows what it's trying to do for their customers, there is a challenge in terms of like what platform to use, how to design that platform to really meet their business platform and our business needs. And we have a playbook in how we help them. The platform itself is more of a substrate, and you can build things on top of it. And even if you acquire something like Azure or Google off the shelf clouds and you use all of their components, there is still a technical design, engineering, and build challenge after that. So after a business design and platform design, there's a technical design, engineering, architecture, and build challenge. And for that, we generally use a framework, and we'll give you a glimpse of that as well today. And then after all that's built, there's a management challenge, which is, okay, this is all up and running, how are we going to manage it? So we have an approach to do that. In most cases, what we see is that after people have the knowledge on how to do things right, that there are two major groups of implementation challenges. One is cloud engineering and operations, and the other is data engineering and operations. We're not necessarily going to cover front-end applications, how to scale those. Also, although that's a separate subject, it's related to the design of the data platform. But data engineering operations and cloud engineering operations is essentially the platform, if you will, on top of which businesses can then deploy applications or suites of applications or microservices or whatever they need. And we're going to talk about microservices. We're going to talk about application architecture, but our focus today is, and for this series is really about data, right? It's about how data flows in a business and how to make it fluid so we can achieve this thing called enterprise consciousness. Businesses have a big challenge. They want to do something great. And of course, businesses will hire different people and they'll grow the team, and they'll have leaders and managers and the employees and contractors to actually do the work. But the challenge of the business, and maybe some people will not agree with me, the challenge of the business is not to maintain technology. The challenge of the business is to find customers and make them happy and make enough money to pay for everybody's livelihoods and make sure that shareholders are happy. And now we're talking about the triple bottom line of also social equity and environmental equity. But those are the challenges that businesses have. And so we want to differentiate business challenge from like a platform challenge and a technology challenge, in that most people think a business challenge of doing a business, technology transformation is a business challenge. I don't think so. I think it's related. The business may have to think differently in the modern world of how they work with customers, how they get customers, how they make them happy. But ultimately, a business is about business, about delivering a good or service. Technology is an enabler. It's always been an enabler. Business has been around for ages. Technology is an enabler for business, but technology in itself is really nothing except a toy. And today, the businesses that are trying to be relevant in the modern age, if you think about brands from 20, 30 years ago, or let's say before the internet, a brand's presence in terms of headquarters, retail locations, or branch offices was the platform. People showed up at an office and then they did work on paper and files, and then eventually computers came along and there were local networks, and then eventually things connected to the internet. Today, that quote office and branch office and retail location is all digital. If not, most of it needs to be digital in addition to physical infrastructure. It is all digital in some cases, and these are digital first organizations. And digital first organizations are companies like Uber, Amazon, you name it, right? All the FANG companies, and I really think that's a dumb acronym for Facebook, Apple, who's the other one? Netflix, Google. They're more companies that basically are at that large, and they use the same technologies. But the big FANG companies and companies like Microsoft, and you can even go back to companies like Oracle. All of these companies have some sort of digital presence where they need to think like a digital first company, even if they started off 20, 30, 40 years ago. And the way they can get to enterprise consciousness is really to connect everything together in an organized fashion. So, people, process, information systems that are distributed around the world, making sure that they can talk to each other, they can get the things that they need when they need it, with the right, security and governance and everything around it. This chart is a representation of a business platform with 4 general consumers, so partners, customers, and employees, and things. And these 4 general consumers have each their own part of the platform that they interact with. So there are IoT platforms that help things interact with the business. Customer experience platforms are for customers. Partner ecosystem platforms are for partners. And then information systems are for employees. There's one area of the platform that sits inside all of these, where the consumers of this platform are actually the rest of the platforms, and that's data and analytics. Right? The only consumers that data and analytics has to worry about are the IoT platforms, the employee information system platforms, the partner ecosystem platforms, and the customer experience platforms. There are interfaces to data and analytics, such as business intelligence. But at the end of the day, these engines, like nobody's really using them. They're just kind of running in the background. And if done well, we can get to this enterprise consciousness, where current business information is available to the users, the customers, the partners in the swiftest way possible. Of course, within the bounds of reasonable cost. If everything were to move at real time, it would be very expensive. Very, very expensive. Business information is generally available to the enterprise, siloed only by security and governance, which I mentioned. Like, if all the data was available to all the people, then it's kind of a pretty crappy company. And what I mean by that is, it's okay to have open knowledge inside the organization, but HR information shouldn't be used, shouldn't be accessible by everybody. Financial information should be protected so that it can't be leaked to the market. I mean, there's a lot of reasons why you have security and governance. It's not just about control for the sake of control. Data platforms make use of appropriate resources for hot versus cold, raw versus enhanced data. And what that really gets at is that not every piece of information needs to be accessible by everybody right now. Data for 2020 financial performance for a company, all of it doesn't need to be accessible. Maybe the averages that then roll up to other views, sure. But the core raw data probably doesn't need to be seen by everybody. In fact, there are these data analytics processes that I had the pleasure of working with, where they have to do an average of 20 years of information. And I'm using the word average loosely because it's just an aggregate operation where everything needs to be quote seen. But actually they don't. Since they're dealing with numbers, there are ways to roll up aggregate processes so that they can have the cold data, the raw data sitting in an archive, but then higher order averages can be accessible by data processes. And again, this is not the full list of things that make a business have enterprise consciousness. A data platform can have a lot of integrations, and it can enable a lot of things in an organization. And then there are many other things that are needed. This is what I think are the most important. But this last principle that I'm outlining here is, it seems kind of impossible for some companies, which is that data platforms are available, redundant, always trying to achieve a RTO of 0. Now, if you're not in data administration, you may not understand what these acronyms are, but these acronyms stand for recovery point objective and recovery time objective. So recovery point objective would be how far back, if there is a catastrophe, do we have a backup of the data that we can come back? So if our latest backup was, or if we do backups every day at midnight, and if we had a failure, catastrophic failure, then our RPO would be less than 24 hours, right? Even if it was at 11:59 a.m., at least the last 11:59 p.m., at least the last backup would be within 24 hours. So that's a RPO of 24. If you did a backup every hour, it would be less than an hour. Recovery time objective is how long does it take to take that data and make it operational again. So if you had a recovery point objective of less than 24 hours, so your maximum is 24 hours, your minimum would be maybe an hour, but it still takes 8 hours to get everything up and running. or 20 hours if you don't have any automations. And that's why you need automations, by the way, for infrastructure and software. But let's say you need at least 8 hours. Then combining RTO and RPO, you're having probably a maximum of 30 hours, right? Minimum of maybe 9 hours. What is 9 hours to a business that is 100% digital, where all their money and all their customers, they interact with everything online? That's basically death if it's a big company. 9 hours of downtime is death because the customer will go somewhere else and buy. This is why Amazon created global data centers. And then they sold it to the rest of us so we can basically pay for their technology. They made a global platform for themselves that was redundant so that they wouldn't go down. Now, that type of technology has been commoditized, so it's available to everybody. But RPO and RTO of 0 is a tall ask. Actually, it's hard unless you design the system from the very beginning to be like this. So that's enterprise consciousness. Data being available to people within bounds. It's protected in appropriate ways. It's available when it needs to be and not available when it doesn't. And the system never goes down. And what that enables people to do is to really work at highest efficiencies, not having to worry about, am I going to lose my information? So now we know what the business challenge is. How do we do it with the technologies? And how do we do it with the platforms? The platform challenge is basically, how do you actually take your existing platforms, right? The ecosystem, partner ecosystem platforms, the customer experience platforms, the information system platforms, and the IoT platforms. How do you connect all those things together with your data and analytics platform? And this is a super simplified picture of a data platform. And I'm going to say data platform as a shorthand for data and analytics platform. A data platform has a lot of pieces today. It's not just a database. There can be a relational database. It can be a NoSQL database. There can be a data warehouse, 3 different technologies generally. There can be an analytics engine, a stream processing engine. But the data comes in basically the same way, and it goes out in basically the same way for all businesses. There's some API where data can be retrieved once it's processed. There's some cloud apps that are connected to the data directly or indirectly via API. And then there's servers and devices where events can go into. And that's how the data comes in as well. Users are using cloud apps. It puts data into the system, or their APIs, or their servers and devices, things that bring data into the system. And all platforms can be basically put into these 3 categories. Customer experience platforms generally are cloud apps. Info system apps are cloud apps. Partner ecosystems are basically a combination of cloud apps and APIs. IoT systems are basically a combination of the devices and how they collect data and maybe some APIs. So that's a super simplification of the challenge, but the inputs in a data platform and the outputs are relatively simpler than the categories of software. From a technical perspective, we can break them down and say these are the lowest common denominators. So at which point does a business think about enterprise consciousness? Well, they can't really do it here when they have business silos. They can't really do it here because they haven't standardized the technology yet. But they can start to do it here when they have standardized technology, and then they're starting to standardize their enterprise processes and data. And after that, the business can be more modular and can be more componentized, and they can squeeze the strategic value. If you try to do enterprise consciousness down here, you're just going to have to do all this anyways. And here's an example. So business silos, these are like small business apps, but they apply to any company. So QuickBooks, WordPress, Google Drive, some other random application, custom application. They're not talking to each other or not hosted on the same platform. And so there's a decision to say, let's standardize on Docker or Kubernetes to run everything on Docker or Kubernetes. It doesn't matter what app language it's built on. No, let's do that. And we're not going to use PHP because it sucks. Right? That's a standardization decision. Then you can think about the data and say, how can we optimize the data so that these standardized applications can use and reuse and process that information? Right? And we're not going to talk about business modularity today, but essentially enterprise consciousness is right here, getting them here so that they can be more modular. How do we take this? These are just some SaaS applications, not to mention there's custom applications. How do we do this? Well, the biggest challenge I think is to curate the systems and say we're just going to use these. That's a part of standardizing the technology. Got to have the right people, especially because the tools that are out there are built by different companies. And you're not always going to have the expert for Salesforce in your team. You're not always going to have the expert for WordPress in your team. Even if you're leveraging a managed service provider for some of these technologies, their support included may not be what you need to really get dirty and into it and make it work. And then of course there's the how do we connect it all together? That's an architectural challenge. But I want to super simplify, like, what are you trying to do with all this stuff, right? So if we go back to this picture here, right? What are these tools doing for these end users, partners, customers, employees? Right? What are they doing? And I posit that all of them are basically trying to do three things. Find information, analyze it in some way if it's not already pre-analyzed by machines, and acting on that knowledge. And that could mean sharing it. It could mean to then create new data products and then share it, or to just use that data and do something physically with it. So like when a Uber Eats delivery person gets a notification that they need to go get food from a particular restaurant and then take that food to somebody's house, right? In that case, the enterprise consciousness is representing the person did not have to go find that task. The system assigned it to them. They don't have to analyze what is the closest restaurant to go pick up the food because the system assigned it to them. And they don't necessarily need to find the best route to the restaurant and then from there to the person's house, because either Waze or maybe Uber is also trying to do it now, route optimization is already done. All they need to do is to just do the work, which is pick up the food and drop it off. Okay, that's an example of enterprise consciousness in action. So I know we're at a data talk, right? So what does all this have to do? Well, a business has data everywhere. And how data is moved and processed and then sent to people or things is how a business runs these days. That's just how it is. We have a playbook in how we help people, design the platform and architect the platform and basically, manage it. And you can go to platform.anant.us to find out what at least the main core principles of it. But data is at the core of every business, right? And however you do it, whether you cobble together your own or you use a technology, ultimately, it's a data problem. Ultimately, it's all a data problem. Two applications in a business create a data problem. And I can prove that to you later. But the moment you have more than one application, you have a data problem. So in fact, I would say the moment you have more than one table, you may have a data problem in a database. Here's just it's a mock-up of a data platform, but it shows that there may be several stages, and not every business is going to have the same stages as every other business. But I like to think about simplifying the goal of enterprise consciousness to be, how can we streamline, organize, and unify people, processes, information, and systems? And if we think about unification. Unification is bringing things together for people, process, informations, and systems. Organization is about properly referring to things so that a user does not necessarily need to go find it, or a system process does not need to go fetch information from across the world. So making it so that each process or person can do the things they need to do easier. And then streamlining is about doing it in the most efficient way possible. So if you just hold to those three concepts of data platform should be streamlined, organized, and unified, in whatever way you get there, you're going to achieve enterprise consciousness. I guarantee that. Because first of all, you're not going to achieve it. I'll take that back. You're not going to achieve completely real-time business at scale because of the speed of light. There's nothing faster than it. And even with quantum databases and quantum networks, we have to see. Maybe that will allow us to do completely real-time everything. But up until that point, you're always going to have a little bit of latency. It may be 1 microsecond. If you get there, hallelujah, because Google doesn't achieve that. Nothing happens in 1 microsecond. But if you continue going towards streamlining, organizing, and unifying, you're going to have some semblance of enterprise consciousness. And the best way to measure that, I think, is, are the customers happy? Are the employees happy? And are the partners happy? And are the IoT systems able to get and send data quickly? And the things are basically serving all the people, right? So what I mean by happy, in a perfect world, the people are all capable, the processes are all well designed, and so information being where they need it in the right place at the right time is what allows them to do their job in the best way possible. It gives the customer the information when they need it. Like when I'm told the Uber Eats driver is 2 minutes away, that I should make my way down to the door, I'm happy because I don't have to get the call. I can just be there the moment the person comes in, at my door. Things happen in a streamlined fashion. We talked about the business challenge, the platform challenge, and how to design it to make sure this happens. Now let's look at the technology and management challenges. I think that well-meaning individuals try to solve the technology and management of technology, not business management. They try to solve this problem first before thinking about what is the business actually trying to do, what is the platform supposed to do holistically. And what ends up happening is they come up with solutions that are half-assed, not because they wanted it to be half-assed. They did a full-assed work. They did the best they could. But if you look at a bigger picture and you didn't see the big picture, the result is half-assed. And I'm saying that from taking ownership perspective, right? If you knew that there was a bigger picture and you didn't look at it, and you spent all the time and resources solving a problem that you thought was just in this little realm, then you are the only person that's responsible for having a half-assed solution. And I'm saying that not just like as a philosophical belief, I'm just saying that that's reality, is that people will try to absolve responsibility by saying, well, nobody told me what the business challenge was. Well, did you ask? Nobody told me what the platforms were that we needed to connect. Okay, well, did you ask? I wasn't supposed to ask. Well, who told you that? And maybe you're working at a place that you're not allowed to ask questions. Go work somewhere else. Here's some challenges that we see. So people will have a certain tool set, and they'll think that it can do everything. And that's basically a resistance to change. And when we get into the world of real-time businesses, enterprise consciousness, moving data as fast as possible, some old technologies just don't cut it. And even though I have a set of logos here, I'm not saying that that's the solution.
But the solution is not just to use a existing technology until it works, or to bring in a new technology because the old one doesn't work. It's really to solve problems related to a technical challenge, related to a platform challenge, relating to a business challenge. Right? The problem is not RabbitMQ sucks or Redis sucks or Mongo sucks, because Mongo is web scale. That's not the problem. The problem is the business needs a scalable and resilient message delivery. They need to have real-time data storage and retrieval around the world. That's the challenge. That's the goal. It's not to replace or reuse a technology. That's not the challenge. So you may find that if you pursue a certain set of goals like this, and these are coming out of the enterprise consciousness thought, like mindset, and our playbook, it doesn't mean you should or should not use Mongo. That's even though I don't like Mongo. That's not the point. Technology can do something well if it's meant for that. It may not be meant for something you're trying to do. So you need to either sideline it for what it's good for and then use something else that's better. What we've seen in the last 7-8 years is people are progressing towards hybrid data and analytics. They still use the quote old ETL, extraction, translation, and loading with a data warehouse, and they wait for these. So ETL still works. They still use it, but this is a synchronous process. So let's say if you're doing a backup or you're doing an ETL that's once every 24 hours, that data is only as old as the last time it was run. That may work for some information, right? The hot and cold. May not work for everything else. But it's a hybrid system. There's people that use the old ETL data analytics tools, and they also use the new. But the new way of thinking is not just a set of technologies, just like ETL is not a set of technologies, just a way of doing something. The new way of thinking is that data is everywhere, comes from everywhere, changes everywhere. And we need to bring these things together to have an idea of what the customer is. Customer is interacting on Twitter, LinkedIn, email, the website, the mobile app. Do we know who our customer is? So customer 360 can do that, what that means. Is our customer 360 data 2 days old because our ETL process takes 48 hours? Or is it a minute old because we're using the events generated by all these different systems? The new way of thinking also can include federated data sets. We don't have to own all the data. So there are, this is an old picture, and there's even more, but there are all these public data sets available out there that you don't necessarily need to bring into your data warehouse, but it can be used to enhance information. So combining data everywhere, it's happening everywhere, with a need to create good data that you and your customers and partners can use with external data sets that you don't have to reinvent or recreate. What you have is the ability to do things in real time. And some of the ways people have done it in the past is streams, queues, and buses. This is not new technology. That's why the new way of thinking has nothing to do with the technology. The technology has always been there. It's just that to try to do it at scale for very, very large customer bases that are, like 30 million customers across the world doing, a million things a day. These older technologies like enterprise service buses that are built in the monolithic era, they don't scale. But the concepts of streams, queues, and buses that we've learned on how to do them right, they still apply. We don't lose all the work we did for the last 30, 40 years in IT just because we're thinking of a new paradigm of real time and we're thinking about real time globally. We don't lose all of that work. In fact, the best practices in an enterprise service bus are what people have to reinvent in some of the newer technologies because they're just not mature yet. Certain technologies go well together in this real-time global world. Again, these logos are just the ones that we work with, and I'm not saying that you should use it, but You can do the same thing all on Google with Google native technologies, or on AWS, or on Azure, or on your own hardware. The reason we like these logos of Kafka, Spark, Cassandra, Flink, are that these logos, these technologies are open source and they can run on our hardware, they can run on all the different clouds. That's why we prefer them. Doesn't mean you have to use them in every scenario. They just happen to work well at scale and in real time if you wanted to. It doesn't hurt. And there's a big community of tools now that are out there that are new and innovative. There's always new stuff coming out. And I put into that mix the cloud technologies, as you can see, right? Kinesis, Lambda, DynamoDB, Cloud Spanner from Google, Azure Cosmos DB. These are technologies that only these cloud providers provide, but they are real-time components that you can use. They're great. The real takeaway from this slide is don't go try to make your own thing. Somebody's already done it. I guarantee it. Somebody's done a good job of it. And if they haven't, you can make something better if you're Google, if you're Facebook. Like even Uber, DoorDash, Netflix, they don't go make their own database. They use these technologies that are on the slide here. And so unless you're Amazon or Facebook or Google, or maybe Apple, even Apple uses all this stuff, right? Facebook, Instagram, for example, uses Cassandra, right? Discord and I think Medium uses ScyllaDB, right? These big companies, they don't go reinvent the wheel. They just use what's out there. Certain technologies have been proven over and over and over again. You go to Google Images and you look for Cassandra, Spark, and Kafka, you will find no less than 100 good reference architectures that somebody has done. And you can see which companies they're being used at, because everybody has an engineering blog now. It's a cool thing to do, where they say, hey, here's how we solve this problem. And there are many use cases, at least for this set of technology. But even if I didn't show you these logos and I didn't say Cassandra, Spark, and Kafka, these are problems that people are trying to solve, or they're goals that they're trying to achieve, and they can do it in a variety of ways. We'll get into that in a second. But a Lambda architecture, it balances stream and batch processing for reliability. Machine learning can help deliver predictive and descriptive analytics in real time. Master data management, which has been around for a while, can ensure that all the data is consistent all the time in all the systems. Real-time customer experiences is what allows customers to be informed, the right recommendations to be made at the right time. And then real-time information systems for team members, they're always informed of what's going on. So if there are so many different technologies and so many different ways to connect all this together, where do we start? And this is our framework, and I didn't say we invented it. We learned it by seeing all of these reference architectures that people put out publicly, and we've seen them, different variations of these things used at our customers, but they all happen to have the same general makeup. So we have 3 white papers that represent our playbook, our framework, and our approach. But in our framework white paper, what we did was we researched and organized these tools. We curated them into a framework so that the decision is a little bit easier in terms of what to use. And this is just a small preview, but we look at each data platform as it connects to the full business platform as a computer. Unfortunately, you just can't go buy a computer. Like, you can't just go to Best Buy and say, I want this HP or this Dell. And if you're, in my age bracket, you may remember that you bought a Mac or a IBM, or you would buy what's called an IBM clone. And until Compaq and HP and Dell came along, what that meant was you would buy your own motherboard and a case and a CPU, normally Intel, and then eventually there was AMD. You would buy your own memory, and you would put this stuff together. That was how you got a computer, the way that you wanted it. You couldn't get a badass computer by buying a Mac, although they were expensive, they were good enough. If you really wanted a badass computer, you would build it on your own. You still do that today. Gamers still do that. So I look at a data platform that connects to the rest of the business as a computer that we have to build every time. So when I think about a data platform now as a computer, I try to categorize the components as analogs to the computer world. So major components of a data platform: a persistent queue, right? It's like a RAM or a bus. Queue processing and compute is similar to a CPU. Persistent storage, disk, but also you can consider RAM. Reporting engine is not in this grid, but I would say that's kind of like a display, like your monitor. Orchestration framework, your motherboard. Although some of the stream processing technologies, you can also have kind of a way things move around. So you can consider that part of the motherboard as well. And then the scheduler is kind of the operating system. What is running all this stuff? And the stream processing framework, you can also think is a way to consider, you can consider that as an operating system as well. And there are strategies that you can use to build your computer. So you can have a completely cloud native on Google or AWS or Azure, right? That's a strategy where you use everything that Google, AWS, or Azure has to offer natively. And there's a reason you would do that. Self-managed open source, right? You get this stuff, you install it. That's one way to do it. Self-managed commercial source, meaning it's open, but some company is providing commercial support and providing bug fixes and patches, and you're still maintaining it on your own. Or managed commercial source, meaning you pay somebody, or managed open source is another option. You pay somebody and they're hosting the system for you, but it's not necessarily, let's say, Google PubSub. It could be Confluent Cloud, which is Confluent. They're a big contributor to Kafka. They provide it, and it's a managed commercial source. Ivan has a product just like that. It's managed Kafka. So these are different strategies, and you may choose to use one strategy for one of your layers. You don't have to use the same strategy for everything. Here's an example. A company is transitioning from on-premise into the cloud. I would not recommend that they change everything to use cloud native technologies. It would be a big effort. What I would recommend is, what are the things that you can move over easily from on-premise to the cloud? Well, if it was open source, and you're probably using some sort of open source technology if everything is on-premise. So let's say you were managing your own Confluent Cloud and your own data stacks analytics. You could say, well, you know what? Data stacks analytics, we can use Google's Dataproc, which can run Spark. Instead of using Confluent or self-managed Kafka, we're going to pay Confluent to manage our Kafka. So as long as the interfaces aren't broken between these components, you can still get your computer from on-premise to the cloud and beyond, which we're going to talk about what beyond looks like. But that's neither here or there. Like, if you don't look at the big picture, what's going to end up happening is that you just see what you see. Here's what we use. And the only way to do X or Y or Z is what you see. So having a bigger picture allows you to make better decisions. Here's a simple picture of the framework. And when we say framework, different businesses end up having different components, right? But note that a good framework would allow you to do the same box, the same computer on any hardware. And you have options for different things. So for example, query layer could be AWS Snowflake, could be AWS Redshift, it could be BigQuery. You don't have to use what a particular organization or cloud is providing. You could do Presto, which is self-hosted if you wanted to. I'm not going to spend too much time here. And then finally, approach. So you have your technology. You have everything connected. And then your lead decides to go work for Capital One. I know Capital One is a support of the data community, so you guys should sponsor our meetup. So somebody leaves your team and goes and work for Capital One. So then what do? You're scrambling. Who's going to do X, Y, Z? Mature organizations will have good knowledge transfer practices in place. They'll have, a good confluence. And really mature, really big organizations will have what's called ITIL or TOGAF frameworks to basically allow transitions in an organization, whether it's a system or service organization, or it's a person transition. You can withstand those changes. So the approach is basically, how can we set up, train, administer, customize, and manage the knowledge for a given system? And this is just a starting point. It's a simple starting point, and it's supposed to be something that anybody can get started with. We're a small company. We have systems. We could use very simple, parts of this approach to document how our things are set up, where to find the training information. Is there any specific training that we need for our team on top of the product? What are our administration practices? How have we customized this tool or technology? And then where is the knowledge inside and outside the organization that relates to this technology? And if that's all organized, the next step could be, can we take any of this stuff and automate it? Can we take any of this stuff and automate the transition of configurations? And that's, again, towards the maturity, right? You're always trying to have a better approach to running your team. This is just kind of a skeleton to get started. So before we end today, I want to give you guys a context about why it's important to think about business goals and platform goals, and not necessarily technologies. And I think the approach is perennial as well. But the reason is that the context changes year after year, month after month. So if you think about the enterprise consciousness principles, and you think about the playbook concepts we talked about, and you think about the framework in general that can continue to be updated, and you think about the approach, it doesn't matter what technology you use today. You could change next year, but still be approaching enterprise consciousness. So in the fast data world, for example, you can see, relatively speaking, in the last 8 years, how things have grown. Right? So and there's always cycles, right? There's always cycles. If you look far enough, there's always some up and down. And usually when we see a downtrend in Google Trends, okay, remember, this is relative popularity. Okay, it's relative popularity. It doesn't mean that it's the same, there are less people using it. It just means that people are searching for other things. So population is always growing. There are new technologies. So just, you have to understand what Google Trends are to understand that. But relatively speaking, we can see, for example, here, Cassandra, and we can see Kafka, right? Kafka still has room to grow, I think. Spark, I think, will continue to grow. Airflow's coming up. It has some competition. I think it's going to stick around for a while. The general awareness beyond fast data, for example, is to think about, well, Python is very popular. Maybe we should invest in using Python for a bunch more stuff, because we'll be able to find employees and contractors that know Python. APIs are popular. Now, Spark and Postgres, even Postgres is a really, really popular database, right? It's been around.
And then Spark, I'm just comparing two things here, right? They're so low in terms of popularity compared to these other two. Doesn't mean that people don't use them. It just means more people are looking for Python. More people are looking for APIs. What does this have to do with enterprise consciousness? At each age, at each year, technologies are going to come and go. And that means that people will have a particular skill set or not. And so if you're not aware of what's happening in the market, then your goals of enterprise consciousness may be compromised because you didn't have the right talent in place, because you didn't see the trends of what's happening in the market. Databases, why are they falling in popularity, relatively speaking? My opinion is because people don't necessarily need to use databases anymore. They just use an API service, like a backend as an API. Why build an API if you can just use somebody else's API backed by their database? It doesn't mean that people don't do it. It just means that there's other ways to achieve the same goal. When we talk about microservices and APIs later, we'll find that relinquishing control to somebody else may be a convenient thing, but when we get into comprehensive data and analytics, it means more work later on, because then you need to bring the data back. We'll talk about that later. And let's say, for example, just in the real-time databases, there's still competition. There's always ups and downs. And professions, coming back to the human resources problem in achieving enterprise consciousness. Certain roles are more popular. Software engineer is more popular than data engineer. Doesn't mean that you shouldn't, pursue data engineering. What it means is that there's a higher demand because there's less supply. More people actually, even if they don't know they need a data engineer, they need a data engineer. They don't need a software engineer. I'm not saying software engineers are good or bad. I'm just saying that software engineering is a very broad, type of profession. Data engineering can fall underneath it. User interface engineering could fall underneath it. You can name a bunch of different things. They fall under software engineering. Data engineering itself is a very niche profession. But DevOps is on the rise. Data analysis is on the rise. And these things are important in the modern platform because you have to serve the customer. And the customer is not just the users in your organization. You have to think about the developer experience. The people that build the systems need to have a good experience as well. It's not just about serving all the end users and things. If it really sucks to maintain your system, then you're going to have churn in your team. So having good DevOps, data ops automations in place allows you to have a bigger, better system for years to come. And so I'm not surprised that DevOps is rising because people don't want to wait 3 weeks to get a release. They want to make a fix and they want to see that fix out by afternoon. And then part of DevOps and data ops is thinking about how to reduce human error, because things are automated, they're less likely to be error prone. Infrastructure, lots of infrastructure stuff come and go. Docker is still very popular because it's part of Kubernetes. People use Kubernetes. They need to use containers, and Docker is the easiest way to make it. Well, that's it. I know we're over time. Eventually what I want to do is after we cover the overall landscape, I want to go deeper into each of these technologies. So that's the next set of sub-series. We're probably going to have 1, 2, 3, 4 sub-series after this one is complete. So I want to thank everybody for joining us today. Sorry, we're wrapping up a little late. And I don't think we have time for questions today. So send them on YouTube or email us at solutions@anant.us. And if we need to explain something in the next session, we will. Thanks, everybody. Have a wonderful rest of the day.